welcome to the launch of the MIT Future of Data Trust and Privacy Initiative. This is our newest initiative here. I'm Lori Glover. I'm the Managing Director of Global Strategic Alliances for CSAIL, and I'll be serving as the Co-Executive Director of this initiative with Taylor Reynolds. This initiative is a collaboration between IPRI, which is MIT's Internet Policy Research Initiative, and CSAIL, MIT's Computer Science and Artificial Intelligence Lab. We're all really aware of the challenges of data management today. Many countries and states are making laws that address these challenges, but they often lack technical alignment. The capabilities aren't really aligned. In this initiative, we are going to focus on technical approaches to today's challenges with data management, privacy, and security, opportunities for dialogue on policy, creating new policy-aware technical platforms and applications, and advancing research in technical areas, including database systems, applied cryptography, AI and machine learning, data portability and new information architectures, and human-computer interaction. The faculty directors of this initiative are joining us today, and they are Danny Weitzner, who is the founding director of IPRI, and his research pioneered design of accountable systems as a new approach to privacy and interaction between cryptographic technology and surveillance law. And Srini Devadas, who's a faculty member in electrical engineering and computer science and a CSAIL researcher, whose research focuses on computer architecture, computer security, and applied cryptography. You'll hear from both Danny and Srini today. Through initiatives, we partner with companies so we can work together to address hard challenges, significant issues that companies are dealing with, to which there's no current commercial solution. I want to thank our founding members who are also joining us today for supporting this initiative. MassMutual, who's represented today by Adam Fox, their head of data. Capital One, who's represented today by Bayan Druce, who is Director of Applied Machine Learning Research. American Family Insurance, who is represented today by Brad Burke, who's their Enterprise Chief Data Officer. And again, you'll hear from each of them also today. And now, I would like to introduce Professor Daniela Roos, who is the Director of CSAIL and the Deputy Dean of Research for the Schwarzman College of Computing here at MIT. We'll talk about the vision for this initiative. Daniela?
Hello and welcome everyone. I am so excited to be here with you virtually as we launch our new initiative focused on the future of data, trust, and privacy. And I'd like to observe that it's no overstatement to say that data drives every industry and the entire global economy. But data only has meaning and value if we trust it, and if we have some amount of comfort in how it's being used. And that's why it's not enough to look at topics like big data in the abstract. It must be thought of in the context of what safeguards we have to put in place for data to work for us and not against us. And at MIT, we've spent decades thinking about the importance of privacy and trust in computer systems. In fact, CSAIL has its roots at MIT as Project MAC, Machine-Aided Cognition, which was an initiative in the early 60s, more than 50 years ago, if you can imagine, that created one of the world's first time-sharing systems called the Compatible Time-Sharing System, or CTSS. And CTSS allowed multiple people to use a mainframe computer at the same time, and as such is widely regarded as the birthplace of the first ever computer password. During the ensuing years, we became home to some of the world's most prolific and influential cryptography researchers, from Professor Ron Rivest and his work on public key encryption to Shafi Goldwasser and Silvio Micali's invention of zero-knowledge proofs, and today's efforts on homomorphic encryption. Now, in the last few years, we've continued to put significant resources towards these efforts with the 2015 launch of the Internet Policy Research Initiative, led by Danny Weitzner, as well as MIT's campus-wide Trust and Data Consortium, which focuses on helping organizations adopt a holistic approach to cyber protection. The initiative we're launching today is the next big step in furthering the scholarship and innovation that takes place here. And we're excited to have you on this journey with us. Now, data is central to AI, and AI is central to much of our current C-cell research. It is enabling advancements in many industries, and I'm optimistic about what the future holds. I believe data-empowered AI will improve our lives in many ways, some of which we've only begun to imagine. But my optimism rests on the belief that we, as educators, business leaders, and policymakers, have the ability to take action to control the challenges that this technology also creates. And that's what the future of data policy is about. And this is what we are here to discuss today, how we believe data-empowered AI can make the world better, the perils we must account for, and some specific opportunity areas where our actions will determine whether or not the story of data has a happy ending. And to be frank, we can only achieve the best outcomes if we address some big challenges that stand in our way and that are the defining pillars of our new initiative. For example, the lack of interpretability and robustness in today's AI systems leads to significant issues around trust and privacy. We need to address these technical issues, and we need to develop an ethics and legal framework for how to use data for the greater good. As we gather more and more data to feed into AI systems, the risk to privacy grows. So does the opportunity for authoritarian governments to leverage these AI and data tools to curtail freedom and democracy in countries around the world. But these problems aren't like the pandemic. We know they're coming, and we can set out to find solutions at the intersection of policy, technology, and business in advance, now. And this is what the mission of our Future of Data initiative is all about. Now, privacy is an example where underlying technology needs to evolve, and C-cell researchers are leading the way. And let me give you just an example of data-enabled possibilities and privacy challenges in the context of medicine. AI and computation hold so much potential to help in areas like healthcare. Recently, MIT researchers were able to leverage AI and a lot of data to synthesize a new antibiotic. And this has created an opportunity for us to imagine if this work could be extended to synthesize customized medicines allocated to individuals based on their environment and circumstances. And I don't mean personalized healthcare here. I mean an individualized cocktail, one pill that is the right pill for you right now. But of course, to get to this vision, we need data. And anytime we need data, we need to consider the risks to privacy. Regulation can help. And it's time policymakers dove into the difficult work of assessing privacy laws in the context of today's technology. But technological breakthroughs will make this much easier because advances in areas like homomorphic encryption can allow us to use the data without decrypting it. So organizations that need information, like your insurance company, for example, can post queries against the vast pool of data without ever decrypting the data itself. And if we get this right, we can create and learn from the largest pools of knowledge ever created and never risk the types of exposure we see already today. Imagine if you all can get medicine synthesized for your circumstances just in time, just as you need it, in the most effective and optimal way. I think that this would go a long way to addressing our grand challenge of curing disease. Now, homomorphic encryption may sound like a phrase you'd only ever hear walking the hallways of C-cell, but the concept this phrase represents has the potential to impact everyone. And this is why we do need to educate everybody, all the citizens, all our leaders broadly about the scope of the current technological solutions. What can be done? What cannot be done? What should be done? What should not be done? And what must be done? So we need to raise awareness to the impacts of our choices so that we can make the right ones. And this is one of the missions of our Future of Data initiative. And whether you're a technologist, a policymaker, or a citizen of the world, we all have a moral obligation to use data and technology to make our world better and the lives of our citizens better, and to do so in a just and equitable way. The optimist in me believes that we can do that and this will happen, especially if we have conversations like the ones we are starting today. Before I end, I'd like to thank Srini Devadas and Danny Weitzner, as well as Lori Glover and Taylor Reynolds, and our funding partners, MassMutual, Capital One, and American Family. Thank you for your leadership and for believing in our mission. I look forward to our journey together in this program.
Great. Thank you so much, Daniela. And now with that, I would like to welcome Danny Weitzner, who will talk about his research and his vision for this initiative. After Danny speaks, there will be a few moments for questions. So if you do have questions, feel free to put them in the chat. Thank you. Danny?
Lori, thank you so much. And many thanks to our partners, Capital One, American Family Insurance, and MassMutual, to everyone who's joining us today, all 200 and some odd of you. And my special thanks to Daniela Roos, our lab director, my colleague and mentor, for the attention and commitment that she's shown to these issues. Daniela could do very well, obviously, on her own, just as a great computer scientist and roboticist. But as you can hear, she, along with many of my colleagues at MIT, have really embraced the view that we have to take seriously the larger social challenges associated with these new technologies. And I'm really thrilled to be part of this community that's bringing all the creativity and innovation and excitement that we bring to technical challenges to these social and political challenges as well. So as Lori and Daniela have told you, the Future of Data initiative really has as its mission to bring the best technical expertise we have in computer science to the very pressing challenges that we face in our data-driven society. I think it's really no accident, no understatement to say that the cost today of failing to make strategic use of data could never be more apparent. This was said to me by a prominent hedge fund leader who I won't name. But we look around our world, whether it's in areas of sustainability or addressing the COVID crisis, we know we need to make the most of the value and the insights that we have from data. And we have extraordinary technologies that we are able to bring to bear to do that today. But at the same time, the world has really upped the ante, upped its expectations about the care and concern that we will bring to handling data. In 2016, the European Union passed the General Data Protection Directive, which was really a sea change, as many of you know, in how data is handled. The expectation in the GDPR in some ways goes far beyond privacy. It says that we have to be able to handle data at scale with care. We have to know what's happening to all the data that we're processing. And the challenge we face is that, frankly, our systems are not up to that task today. Many companies, many governments, many institutions, many researchers work very hard at that, to be careful with data, to treat it respectfully. But really, we lack the tools in many cases. And one of the key aims of this initiative is to bring our approaches to technological innovation to this set of challenges. It helps, I think, to understand a little bit about where we've come from in technology policy to think about where we're going. When I think of technology policy and internet policy, there are, I think, some foundations that are worth really bearing in mind. There's a myth, I think, that somehow the internet and the data environment was a wild west, and it really wasn't and never has been. We have had strong policy foundations, that have shaped the data environment that we're living in today. Most societies around the world have made a strong commitment to protect free expression and free association. That's been essential to facilitate an information-driven economy and an information-driven society. We've had carefully written rules about how platforms are regulated. We've always, from the very beginning, realized that we have to have global interoperability standards beyond national boundaries to make the internet and information technology work. We've taken, in the first era of internet regulation, what has largely been a light touch approach to privacy. It's not to say there have been no rules, but the rules have been written rather cautiously, and enforcement has been somewhat careful. And we've had very modest security regulation. And we've also made sure, as Daniela alluded to, that everyone has access to strong cryptography to be able to provide technical protections for their data. But these foundations led to really pretty extraordinary results around the world. I like to think of this as the $6 trillion, 3 billion person enabling policy framework. $6 trillion is the roughly current market cap of just these four main internet platform companies. And there are 3 billion people who are online and who got online really extraordinarily quickly, given the history of technology. But there are gaps that are emerging in this framework. To begin with, the US and the European Union are no longer exactly in the same place on privacy policy questions. And China, of course, has taken a very different approach. There are signs that we're moving from a more or less permissionless innovation framework to a much more permission-based innovation framework. And we're clearly seeing increased market concentration in many respects. I think in this, there are also opportunities for us. We have opportunities to create better data governance technologies, more accountable systems, more accountability in our AI environments. And that can help evolve our overall governance framework, but we have to act on those imperatives. In the area of security and cryptography, I think what we've seen is really increasing cyber attacks around the world, whether they're state-based attacks or simply criminal attacks. This poses substantial risk, and one of the areas that we'll be working on in the Future of Data initiative is trying to understand this phenomenon better with some innovative new research approaches that I'll discuss. We have a number of questions about how to regulate some of our large platforms, and we have also, I think, really big challenges about how the world will come together to create the next generation of a globally cohesive interoperability environment. There are real challenges to that. There are geopolitical challenges there, but there are also challenges that are technical challenges that we can really contribute to with the dialogue here. So I think it's safe to say that in many ways, the frontiers of computing are no longer purely technical. And this is reflected in a recent decision by MIT to launch a new College of Computing. This is a major reorganization of how we teach computer science and how we organize research. It entails substantial investment. And what I draw your attention to here is that in the context of the $1 billion investment that MIT has committed to, which will support 50 new faculty members, the largest growth we've seen, by the way, since the creation of the Sloan School, that we've expanded our commitment about what it means to work in the area of computing. And we've said that in addition to just making technical advances, we have to be a place for teaching and research on relevant policy and ethical issues raised by the challenge of new computing environments. So this Future of Data initiative is part of a larger commitment at MIT, and I would say universities around the world to address some of the larger societal challenges brought by computing. I want to talk very quickly about just a few case studies to give you an example of some of the kinds of research that we plan to do in the Future of Data initiative. And as you'll see in both of these cases, this is research that is, number one, motivated by challenges that we've observed through dialogue with policymakers. And number two, it's research, frankly, that depends on collaboration with industry partners as well as policymakers and civil society experts and others. But this is research that we really have to do in the context of new enterprise computing frameworks and with partners in industry and in government. So one of the extraordinary challenges that we face as a global society are the risks of cyber attack. They're escalating around us. All of us have been touched by them in one way or another. And what is striking, however, is that we actually know very little about how to actually address these attacks in a systematic way. There are many CISOs and computer security experts who have very well-honed knowledge about how to deal with specific kinds of attacks, but our understanding of the general nature of attacks and the general nature of risk is really quite limited. And part of the reason for this is that we have very little ability to analyze attacks across enterprises and across platforms. So we've launched this project called SCRAM, which is part of the Future of Data initiative, the Secure Cyber Risk Aggregation and Measurement Project. And our aim is to collect data from a number of enterprises that looks at attacks that they suffer, specific control failures that are the cause of the attacks, and the monetary value of the losses. What this will allow us to do for the first time is to develop comprehensive cyber risk pricing models. And we believe we can get a number of important advances from these models. We will be able to help CISOs make better investment decisions about where to put their cyber investments. Number two, we think we'll be able to improve the quality of cyber insurance that is offered. And number three, we'll be able to help policymakers and regulators to make better choices about how to regulate efficiently to improve the security of the environment around us. And I'll give you just a little bit of an illustration of how we've actually done this. Because companies are understandably reticent to share information about the attacks that they suffer, we've built a data computation platform using the homomorphic encryption technology that Daniela Roos referred to, which enables us to collect data in encrypted form, analyze that data while it is still in encrypted form, and share the results back to all of the data partners without revealing any of the sensitive information about the attacks that companies have actually suffered. To give you a very early sense of some of the results that we're seeing, first of all, what we're learning is that losses actually cluster very heavily with a small number of cybersecurity defense categories. So that suggests we may have a better way to prioritize investments. We've also noticed, however, that just because enterprises implement a given set of cyber controls, it doesn't mean that those are necessarily efficient or effective. So it's causing us to look more carefully at the frameworks that define how we approach cyber defense. Now, I want to talk with you quickly about another area of work that we're doing, and it really has to do with the challenge of building enterprise data systems that enable institutions to comply with the requirements of the new GDPR, the European General Data Protection Regulation. Europe, as people know, really have set the global standard, more or less, the global high bar for privacy protection. And this is just a quick illustration of some of the requirements of the GDPR. I won't go through them all, but what I want to point out is that much of what is required by the GDPR, many of the features that we would want to have in enterprise database systems, whether it's the ability to enforce purpose limitations on how data is used, the ability to comply with individuals' right to erasure or right to be forgotten, or the ability to deal with complex questions such as data portability in a graph computing context, or the ability to explain machine learning decisions that are made. These are all problems that are still not solved in the context of systems that enterprises use today. So we intend to work on many of these problems. Give you one example that we're working on right now. Today's database systems have really no ability to manage data, to handle queries, to build APIs according to the kind of purpose limitations that are required by today's modern privacy laws. Here is an example. We would like to be able to build systems that allow the integration of lots of different sources of data for different purposes, but we'd like to be able to allow the data to be used for certain purposes, such as perhaps a wellness service, but prevent the data from being used for other kinds of services, for example, such as targeted advertising. The old school mechanism that we all live with in today's enterprise systems is a kind of a crude access control system that says a developer or an individual or a service can either have access to data or can't, regardless of the purpose for which it's used. So we lose the ability to assure that the data that we're collecting, that we're holding, is actually governed according to the purposes that the individual has actually consented to. We'd like to be able to manage the data according to specific purposes and permit some uses while preventing other purposes. My colleagues, Mike Stonebreaker, Tim Krashka, and others, and I are working on a new purpose-aware database architecture that will integrate along with the relational database systems that we use in today's enterprises to be able to treat data purposes as a first-class object in the way that personal data is handled. A critical part of what we expect to do, and by the way, I'll say you'll hear from my colleague Srini Devadas on a number of other research directions, and very importantly, we'll be working with our partners in this project to define where our research priorities ought to be to meet the most pressing challenges. An important part of this initiative will be public engagement and efforts to seek real impact with the research that we do. From the time that we launched IPRI, the Internet Policy Research Initiative, in 2015, we've been engaged in ongoing dialogue with government policymakers all around the world on issues of cybersecurity, of surveillance, of voting security, and more recently of AI policy. And it's really our firm belief that we have to create a richer feedback loop between the public policy world, that is policymakers who have to make technology policy decisions, as well as industry and civil society organizations who have a stake in those decisions, and the computer science community. We think that will lead to better informed laws and more efficient regulation. We also think it will help us in the computer science community to make sure that our research is directed at the problems that really most urgently need to be addressed. I want to give you just a quick picture of some of the researchers who were involved in the Future of Data initiative and have been involved in IPRI. And these are researchers in machine learning, in system security, in economics, in database technology, and in a whole number of other fields. And I want to end on the note of just recognizing a number of the students who we're working with. These are undergraduates, graduate students in a number of departments across the MIT campus. Students are an integral part of the research that we do. They learn quite a lot from being able to collaborate with industry partners and with government organizations. Many of these students go on to work not just in academic positions, but also in government and industry and civil society. And probably in the long run, the most important contribution this initiative will make is to train the next generation of computer scientists and other researchers who will really help us address these problems in the long run. So with that, I will be happy to take questions and look forward to the rest of the discussion.
Great. Thank you, Danny. We do have a few questions. One that came through is, how are new solutions and platforms addressing multi-compliance needs to facilitate efficiency?
That's a great question. And what I take the question to mean is that enterprises, whether they're commercial enterprises or nonprofit enterprises like global universities or governments, have to deal with multiple regulatory requirements in how they handle data, whether there are multiple different privacy rules around the world or different security rules or rules about how to offer explanations for automated decision-making. The very simple fact of the matter is that today's systems do a very poor job of supporting the diversity of rules that a well-intentioned enterprise will want to comply with. So what tends to happen is enterprises just follow one set of rules for the entire world for all the data that they have. That's not always a bad result, but it certainly limits the flexibility of being able to perform different kinds of functions with different kinds of data.
Great. So we do have another one. Some companies gather user data, have written into their EULAs the standards of the EU's GDPR. Should an end user trust their commitment to the GDPR standards?
That's a great question. It is the case that certainly most global companies that are handling personal information recently have just said, well, we'll just follow the EU GDPR rules because that more or less covers all the rule sets around the world. And the question is, should you trust that they're following the rules? Well, let's assume that the company is well-meaning. They're going to try to follow the rules. Do they have the ability to actually track how they're using all of the personal data they have in all the different systems and applications and services? Absolutely not. It is a very, very hard problem, and it has to be done through essentially manual audit and painstaking analysis. One of our key aims in building privacy-aware, policy-aware systems is to build better accountability into the systems that we use that handle personal data. So no one should have to worry about the question of whether a well-meaning company is following the rules. They should know that they're using systems that help them to follow the rules. And the companies that may not be well-meaning or may have made mistakes, well, we should be giving tools to regulators to make sure that they can effectively audit these companies to detect rule violations. We don't have either of those tools today, and it's a key commitment of this initiative to build those kinds of accountability tools into our new systems.
Great. We have one final question before we move on to Srini. The question is, can you make data use more intelligent based on use case through the use of smart contracts?
So the question is, can we somehow automate the control of how information is used? Can we somehow bring greater assurance to policy compliance? And the answer is yes, but we have to build into the infrastructure that enterprises are using the ability to detect, as I suggested, the purposes for which data are used, the commitments that have been made with respect to that data, and then the ability to audit against that. So it's great to make a contract that say, I promise to use this data for these purposes, not for those purposes. That's a great thing to do. We want to build systems that can actually make that a reality.
Great. All right. So with that, I want to thank you, Danny, so much for your vision and your contributions. And now I would like to welcome Srini Devadas, who is the co-faculty director, and he will talk more about what his research is and his vision for the initiative as well. Srini?
Awesome. Can you see my slides and hear me, Laurie?
Yes, I can.
Great. Well, good afternoon, everyone. Really wonderful setup by Daniela and Danny. I'm going to give a pretty technical talk, and I want to try to answer this, really the question of the day here, at least from a technological standpoint. Can we achieve private but collaborative analytics and learning? And by that, I mean learning models that are predictive in nature. And I'm going to try and give you a sense of new research, a new project in the Future of Data initiative, but also situate it in the context of work that really has been going on in CSAIL and in the world over for a while. And you've heard about fully homomorphic encryption from both the prior speakers, and I'll describe the new ideas we have that are certainly related, but also different. So being able to outsource computation on private data is becoming more and more important. If you want to get models on large data sets, and these data sets are getting up to the terabyte level, you have to use cloud services, you have to pay for computation. Not every company has the data centers that the Googles and the Amazons have. Of course, the questions are, when this data leaves your premises, what is the privacy guarantee? I mean, have you encrypted it? I mean, homomorphic encryption obviously is a possibility, but what happens when you have terabytes of data? And Danny has talked about applicable laws governing the data. Maybe encryption is enough. Maybe you can get away with something where you can de-anonymize, etc. Usually there's an overhead associated with this privacy guarantee, in the sense that you are encrypting something. For example, the ciphertext is much bigger, the terabytes turns into petabytes. So there's certain limitations associated with any technology, and multi-party computation and homomorphic encryption are no exceptions. And then ultimately, if you're actually going to transform the data, what is the utility cost of this? Are you going to get exactly the same accuracy for your predictive models as if you had run the computation in private inside of your local servers, where you I should say in private on plain text on your local servers? So there's many dimensions here. And if that weren't enough, well, here's more motivation. I mean, especially in the financial sector, but certainly in the medical sector as well. And Daniela alluded to this, aggregating data and getting larger data sets is getting to be really essential to getting good predictive models. And sadly, privacy requirements may just plain preclude this unless technology can save us. And so the questions here are, do we need to trust a central authority? I mean, and that may not be possible. It may not be legally viable. Perhaps we don't need to trust a single person, but perhaps we need to make a collusion assumption. That is, we say that this is private as long as all three parties that we're sending our pieces of data to do not collude. And obviously, we'd like to share this information so we can improve aggregate results. Right. So there's many approaches with differing trade-offs. And so I want to give you a sense of what prior art or state of the art is, talk about a freshly baked approach called Dauntless. That's one of the projects in the Future of Data initiative. And briefly really talk about how we could tackle this really hard problem of collaborative private learning. So first approach is encrypt the data. I'm not going to spend much time on it because it's been mentioned multiple times already. The big question is, assuming the encryption is secure, and certainly there are schemes that allow for homomorphic encryption, and they are secure, provided you believe, for example, that discrete logarithm is secure, or learning with errors is secure, and that's a pretty good assumption. But the big question is, how efficient in general is this? And obviously, there's successes like Scram, but can you do training on ImageNet, for example, in private? And the answer is no, not using the current generation of fully homomorphic encryption schemes or secure multi-party computation schemes, because it takes days to do it in plain text, and it would take years or decades to do it in encrypted form. So you could use secure hardware. There are processors such as Intel SGX that are available in the Skylake processor, where you tunnel into this little enclave inside of the processor, and only there in this enclave is your data decrypted, and at that point it's in plain text form, and you can run your proprietary, for example, machine learning algorithm inside of it. So you're really buying hardware resources, and you're getting strong guarantees about the privacy of the data, or are you? Well, unfortunately, there's lots of attacks that are possible on secure hardware, and a lot of these attacks have been successful at breaking this enclave abstraction. And I've spent a couple of decades of my life thinking about secure hardware, and I continue to work in the area of strengthening enclaves. And there's certainly hope here with respect to protecting against the attacks that we do know about. But there's always attacks around the corner, so this is going to be something that is not solvable in a matter of a short period of time, I should say. You could mediate access. Usually you have a trusted curator. Danny mentioned this as well. Now, if you trust the curator can see the data. And then the question on the other side is, queries leak data from the database. How much do they leak? So there's privacy requirements that go both ways. Differential privacy is a great technology that allows you to perturb your data, so you no longer need to trust the curator. And the requirement is that the effect of each individual on the data should be hidden. So it's not as strong as a homomorphic encryption scheme in terms of security, but it may be enough for our purposes. And it's certainly efficient and general. But there's challenges in practice. When you have lots of data, it works well. When you have small data, it works less well. And at some point, you run out of a privacy budget. And so what happens then? You also perturb your data, which means there's a utility loss. And there's the big question of matching the guarantee that differential privacy gives you with privacy laws and regulations. And there's significant work at CSAIL addressing these challenges. The last ICML conference had 15 papers from CSAIL on this topic. So I want to talk about a new approach, which is related to homomorphic encryption, but we hope that it has, at least in some scenarios, better efficiency properties. And the idea is that you have a data set X, and I called it an augmented data set, and I'll tell you what that means in a second. But you do a private transform, not quite encryption, but something that is a private transform in the sense that X turns into T of X, as you see here, and T of X is not going to give you lots of information. Maybe it gives you a measurable, but a small amount of information about X. And that is the privacy guarantee that you have. The T of X does not leak very much about X. And now you can send T of X off to a server, which learns a model M, and then you get the model back. And then anytime you want to query the model, you still know your private transform T. So you run inference on T of X new, and you get your answer back. The key question, of course, is how much does T of X leak about X, and how accurate is M relative to the model? And this is something that we ask in homomorphic encryption. And the answer is, well, basically nothing for the first, and you get exactly, the same accuracy for the second question, but it may take you a really long time, as I mentioned. So to improve on the efficiency dimension, you have to potentially sacrifice something. And so you can do a few things. And I promised you to tell you what data augmentation was. And the idea is that you could take images, for example, and you could have labels corresponding to the cat and the dog image, and you can mix them up. And you can increase the number of training samples this way. And people use this technique of data augmentation just to improve utility. But we're going to use it to improve privacy, because we're going to take a whole bunch of different images, some of which may be public, that are necessary for our training set to be large. but we can make the training set even larger by mixing our private images that require privacy guarantees with public samples by keeping the weight secret. So lambda can be secret, and you don't have to do this for 2 images. Obviously, you can make out a cat in the mixed image here, and can barely make out the dog there. But if you mixed, in 5 or 6 images, you can certainly get to the point where you can essentially say something about the information leakage and reduce it substantially. So that's data augmentation. And we use that as a pre-processing step, as you see in this picture, which is kind of an information theoretic analog of homomorphic encryption, in the sense that you've done this data processing, then we do this uniform transform on the data that you see over here, if you can see my cursor, but that's the T over here. And then you send this data over to a server, which trains on the model. And then, as I said before, the model is sent back to the user. So you don't want to expose too much to the server, but the basic idea here is you've only shown transformed data to the server, and you're hoping for security and utility. So the main questions here are, how do we choose to transform so we can show our privacy property? And what is the resultant utility? So I've said this multiple times. Hopefully it's you have a good sense of what the problem is. So what we're going to do is we're going to multiply by a random matrix. So think of an image as being a matrix multiplied by a random matrix. This is what you get on the right. And whether you had a mixed cat dog or a dog, as you can see, essentially because you've multiplied by a random matrix, you've done an encryption of the message. If W is a random uniform matrix, the cat and the dog transform. I mean, you can't make out the difference. They are actually different if you look at them closely, but you or I can't tell. Now, the privacy properties correspond to the adversary is going to see a sequence of transformed images. And we can show a very nice result that I'm not going to prove to you, but essentially that there's this giant infinite ambiguity set associated with these exposed images if you multiplied it by a random uniform matrix. And it's as if you took your original data set and multiplied it by what's called a unitary matrix, which is essentially a matrix that has certain properties. We don't need to get into that. But there's an infinite number of unitary matrices that are possible on a real data set, a real valued data set. And that is a nice property that you can show. And you can also show that the transformation is differentially private. And the amazing thing is that these are just really preliminary results, partial results that we've gotten. If you actually do this data augmentation approach and the transformation approach that I described to you, you can essentially match the accuracy. The last column is what you want to look at. The non-private training on MNIST has roughly 98% accuracy, and you can get pretty much close to that. And these are still early days yet. Optimizations to be had still. And so you can do this in a fairly efficient fashion. It doesn't take much longer for the non-private training versus the transformed training. And you get your utility and you have your privacy properties. So as I said, these are early days yet, but we're really excited about potentially using this for larger data sets and having a competitive technique to a fully homomorphic encryption. So let me close by talking about an even harder problem, which I promised to talk about, which is collaborating, maintaining privacy. Multi-party computation protocols allow mutually distrusting parties to collaborate with mild assumptions about non-collusion. Unfortunately, every operation becomes more expensive. Every multiply becomes tens of multiplies, et cetera. So you'd like to minimize the amount of MPC that you do. The nice thing in this dauntless approach is that rather than training or all of the operations in training that are really a teraflops worth of operations, you can just use MPC to agree on a transformation matrix W. So the 3 parties, let's say our 3 founders of the data initiative, agree on this transformation matrix. They don't really need to know the matrix, but it is created on their data sets using an MPC protocol. No single party knows the matrix. This transformed data goes over to the server. You train on it, and the model comes back, and the model can be exposed, and the model can be used by at any given company that was involved in the creation of the model for their own data. Right. So let me close by saying that this is a wonderful space to work in from a research standpoint. I think there's a great confluence of potential impact and technology. And we look forward to working with you to address research challenges, experiment with new technology, and potentially deploy it. So I will stop my screen share and happy to answer questions if there are any.
All right, great. Thank you so much, Srini. Yeah, we do have a couple of questions. The first one is, do you have any sense of the impact of the systems on the need for computing resources and capabilities? And what kind of cost is it to meet these needs?
So, I mean, it's completely a function of the technology that you're using to guarantee, privacy or to give you your privacy property. There's a wide spectrum. I mean, in terms of the technologies that I described to you, the fully homomorphic encryption, would be orders of magnitude more expensive to do computation on ciphertext versus plain text. If you take the MPC protocols, they're a little bit more efficient, but they're still quite expensive. So as I mentioned, you don't want to go do training, based on MPC protocols. Differential privacy and secure hardware are on the other side of the spectrum. The security guarantees that they give you are not as stringent, or they're not as well established, especially for differential privacy. And but then you get your efficiency from that, right? So there's a multidimensional space here with utility, the accuracy of results, the performance costs of optimization, or should I say, well, performance costs of encrypted optimization or private computation, and privacy guarantees. And then now a fourth dimension. Those are the three things that I was thinking about until FOD came around. Then I started talking to Danny and his crowd. And so now I would add a fourth dimension to that, which is the policy dimension. And then choosing the technology that matches, all of these things is, I think, something that is going to keep us busy for a while, right? So.
Great. So another one here has a question about really the future of data trust and security vitally dependent on metadata, and isn't this data itself risky at best and dangerous to use?
Oh, that is such a great question. Yeah, I mean, so I've give talks on anonymous communication, and one of the quotes in the talk is from General Michael Hayden, who's a former director of the CIA, who's said in the past, we kill people based on metadata. So this was a public statement that General Michael Hayden made about 5 years ago, and so there's the level of privacy that we require, I think, for GDPR versus the level of anonymity / privacy that you require for sort of life or death situations in anonymous communication is really, there's a dramatic a difference there, right? There's a lot of work that's going on at CSAIL and Nikolai Zeldovich's group and my group on building anonymous communication systems. There's a paper that I'd be happy to provide to you on Archive, where we are showing how you could do anonymous video broadcasts, hiding all of the metadata. So I'm not quite ready to do metadata private machine learning yet, but it's entirely possible that if the efficiency of these techniques get to the point where you can essentially say you have ciphertext that looks exactly the same, and there's no metadata leakage, no side channel leakage, that we could get there. But I would, it's a great question. I think it's a little bit of a higher bar than I think we can handle right now, but not something that we haven't thought about. Right.
Great. And I have one final question. I think it goes to your Dauntless program. So how can you prevent an attacker that tries to learn the augmentation function?
Yeah, so again, great question. So, the focus of my presentation, which obviously I had to have a sharper focus than I would have liked given the time, was on protecting the data, the learning techniques that were used you shouldn't be allowed to see the data because the adversary is on the server side. Now, once you have a model, and if you want to publish this model and you want to allow people to query this model, there's leakage associated with that model. And it turns out that you can actually sort of you can have privacy budgets associated with some of the techniques that I talked about here, where the number of samples that you expose to the server and the number of samples for inference that you're actually giving an answer back to, they're kind of uniform. They're treated uniformly. So you can imagine that you could have a budget that says, well, you're allowed to have 100,000 queries here, and then after that, all bets are off with respect to this model being exposed. So I mean, I wouldn't call that a panacea, but it's a start, right? So.
Great. Thank you so much, Srini. Really appreciate you taking time and giving your talk today and sharing your research and your vision. Now, the next portion of this launch is to talk to our founding members. They are leading companies who really take this topic very seriously and are wonderful to partner with us in addressing it. We're going to have a short talk from each of the representatives, Adam Fox from Mass Mutual, Brian Bruce from Capital One, and Brad Burke from American Family Insurance. And we're going to start now with Adam.
Thank you.
Welcome, Adam.
Can you hear me all right?
Yes.
Great, thank you. And thank you so much for the invitation and for having me. As Lori said, my name is Adam Fox. I am the head of data at Mass Mutual. I think by the fact that my first name starts with A, I get to speak with you all first. So at Mass Mutual, our mission is to help people secure their futures and protect the ones they love. That's been the focus of our company for the last 170 years and will continue to be for the next 170. But the next generation will, of course, look much different than the past ones, with different opportunities and different challenges. One challenge that we are particularly focused on is the large gap in protection that exists. Many Americans have too little protection or none at all, and this leaves them, as well as their families, vulnerable to any unexpected events. And so we as a company have set some truly ambitious goals to address this gap in coverage, with the aim to really provide more protection to more families. But achieving these goals will really require some fundamentally different thinking about our products, how they're distributed, and how they're services. And we very firmly believe that data and data science are core to this transition. We're focused on leveraging data and data science to better serve our clients and policyholders really across the entire policy lifecycle. Maybe one good example would be in the underwriting process. So life insurance underwriting is not a fun experience. I can certainly say from personal experience, it's not an enjoyable process. It creates a great deal of friction, which ultimately prevents a lot of people from getting the protection they need. It's invasive, often requiring medical exams and lab tests, which very often requires getting jabbed with a needle. It's time consuming. It can often take weeks or even months to get approved. And it's expensive. It's expensive for the insurers, which ultimately translates into higher premiums for our clients, which limits the amount of coverage that some people can acquire, and for some creates a boundary such they can't acquire any. And for some, just the process itself is too time consuming, too involved, and simply creates too much friction to get the coverage that they need to protect themselves and their family. And so from a data science perspective, we recognize these challenges, and we hypothesize that data could be used to address them. So over time, we were able to prove that hypothesis correct. We developed a suite of underwriting models that can identify mortality risk better than a human expert for a fraction of the cost and provide results in near real time. Since deploying these into production several years ago, these models have assumed billions of dollars in life insurance risk. They've saved Mass Mutual and its policyholders tens of millions of dollars and increased approval times by more than 25%. This is just one example of many that would be needed to really meet the ambitions that we've set for ourselves. So we continue to aspire to push out the knowledge frontier, to leverage new technologies, to leverage new methodologies, and acquire new data to provide better products, better experiences, faster and cheaper for our clients. But as we've been hearing quite a bit about today, doing so is really not without risk. As we've heard many great speakers talk about so far, proper governance, proper controls are really paramount. And these must be implemented using the appropriate and often very novel technologies and methodologies to ensure that they're effective and scalable. And we don't just need those technologies, but we need to really think about and understand what are the right controls, what are the right governance structures, and what are the right technologies that are best suited to ensure that the data and all those products that we build upon them are private, secure, and fair. And that's why we at MassMutual are so excited to be part of this partnership. As we've heard others say, that this is really one of the most significant challenges of our time. The precedents that are being set now will have long-term impacts, not just on us in life insurance or financial services, but on our society at large. And so we're very excited to be part of this partnership, to join CSAIL and the other organizations to take a leadership role to address these urgent questions with like-minded groups that share our concerns. We look forward to partnering with those in academia, and industry, and government to develop robust policies and technologies to ensure that a robust governance foundation exists. And in doing so, take another step to fulfilling our mission of helping people secure their future and protecting the ones they love. Thank you, Lori.
Fantastic. Thank you so much, Adam. Now I would like to have Brian from Capital One say a few words as well.
Sure. Thank you, Lori. And thank you to all the organizers of this great event, as well as the co-chairs of the initiative. We're very excited to be participating. I'm going to share a few slides as I go through my presentation. So I'm just going to check to make sure that you can see what I am sharing before I continue. And I think, good. So as Lori mentioned, I am Brian Bruce. I am the Director of Applied Machine Learning Research at Capital One. And it is my function within the company to help accelerate the adoption of the types of innovations in machine learning and AI that are coming out of the leading industry and academic research labs. And when we talk about this initiative and why it's important to us, a big part of how we see the future of data being used at Capital One and how we've been using it to date has been in the domain of machine learning and artificial intelligence. And so, the use of data in an innovative way really goes back to the founding of our company in the early 90s, thinking of new ways to provide customers with consumer financial products, using data in ways that our competitors had not up until that point was really the original innovation of the company. And it continues to be the lifeblood of how we innovate today and how we plan to innovate in the future. And so the use of data, the application of machine learning and AI is really core to what we're trying to do. At the same time, we really want to protect that customer data and their privacy. This is directly aligned to our mission as a company. And as we've all seen, I think, and part of the reason why we're all here is that consumer expectations around how their personal information is used and secured is changing. And it's changing quite rapidly. And that change is being reflected in the kinds of regulations and laws that governments are starting to enact on behalf of their citizens. And it's also changing in their expectations of the companies that they interact with. And it is our goal as a company going forward to continue to try to exceed our customers' expectations, particularly in how we use that information in order to maintain that relationship built on trust with our customers. And as we're doing this, we're observing that there are existing and emerging regulatory requirements, some that are very specific to financial services and banking, and then others are more general, which create a lot of complicated data management requirements. And so as these policies evolve, we need the appropriate mechanisms to allow us to implement these policies, to be compliant with them, but we also need to be able to satisfy a number of potentially competing requirements. Things like, are we able to scale these solutions? Are we able to do so affordably? Are they easy for the people building the technology inside of the company to use? And are they compatible with the existing development life cycles we have around software and machine learning models? So, we're entering this new data landscape. The use of innovative data is absolutely paramount to our future as a company, as well as this change in the consumer expectations. And so this creates a wide range of challenges for us as a company. The first of which is technical, right? Are we able to protect privacy scalably? Are we able to do so in a high velocity environment? And are we able to do so when we have very particular requirements, especially in our use of ML and AI, around model explainability, performance, and auditability? As a financial services company, we are not just regulated in terms of protecting customer data, we're also regulated in terms of how we use models and how we're able to justify that use of models. And so ultimately, we need to be able to achieve a multitude of business objectives and be able to minimize the data we collect and the impacts to customer privacy. As we enter into broader ecosystems beyond just the walls of our company and think about how do we share data across systems, whether that's with third parties or whether that's with industry and academic research labs or other financial services companies, we need to think very carefully about what protections should travel with that consumer data outside the safeguards of what we have, particularly as a regulated banking company. And then how well informed should we be making customers regarding those protections and the controls that will be left when their data leaves. And lastly, this one's near and dear to my heart, is on the innovation side. Oftentimes when there's anticipated change or new anticipated regulation, it could actually stifle innovation. And so the question is, how do we navigate these uncertain times, both in terms of customer expectations and policy, in a way that allows us to continue to innovate inside of our company and inside of the industry. And so we're really hoping that this initiative helps us navigate this changing landscape along three main pillars. One, we want to be able to accelerate the adoption of these technologies inside of Capital One systems. We want to make these business as usual operations for the company. We want to use this initiative to help us understand the future directions of privacy technology and policy and how that can help us define our own strategy as a company. And lastly, is to build capacity for the machine learning engineers and the data scientists inside of our company to understand and develop privacy preserving capabilities. So there are a number of topics that we're very, very interested in that we're hoping to get out of this initiative. These are just some of the ones that are pressing to us. One is obviously the detection of sensitive data, being able to identify when very critical customer information has gotten to places where it shouldn't, either inside or outside of the company. Scalable ways to incorporate opt-outs and deletion requests to enable the right to be forgotten, even once a model has been trained using that data. Providing data scientists and machine learning engineers with the tools to quickly build and deploy models while also preserving customer privacy and maintaining data security. So this can be anything from federated learning, synthetic data generation, differential privacy, the really exciting work in homomorphic encryption. And then how do we communicate these complex privacy systems to our business and to our customer stakeholder groups? How do we empower them to understand what is being done, how it's being used, and the systems that we've been put in place? And lastly, how do we balance all of these different topics that we need to optimize across, whether that's privacy, whether that's fairness, explainability, model performance, and computing costs? We are really, really excited to be a part of this initiative, and we look forward to working with everyone here.
All right, fantastic. Thank you so much, Brian. Now I would like to welcome Brad Burke from American Family Insurance to also talk about his company and his thoughts on this initiative. Brad.
Sure. Thanks, Lori. Again, I'm Brad Burke, Chief Data Officer of American Family Insurance. On behalf of American Family Insurance, myself, and my partner in all things, Peter Settle, our Chief Technology Officer, I'd like to say thanks for including us in such an important journey. We're excited to get to work on such important topics with CSAIL partners at MIT, as well as our fellow corporate partners at Capital One and MassMutual. So why are we joining this initiatives? Those answers are both simple and complex. The simple answer is that at American Family Insurance, we take the job of protecting our policyholders' dreams very seriously. We want our policyholders to dream fearlessly. And a big part of meeting that goal is continuing to earn and keeping our policyholders' trust so that we can innovate on products such as cyber, connected home, connected auto. It's for these reasons we are highly engaged in the topics around the future of data, privacy, and trust. The more complex answer revolves around something that Danny Weitzner was talking about when we were having a discussion. Danny mentioned the goal of this effort to move to policy aware or informed systems. This is an incredibly powerful goal, and there's a lot of reasons for that. First, this data craft is evolving. Working with data has evolved from sort of separate web teams and business system teams and warehouse teams over the years as we've been through the waves of innovation around big data, the API economy, low code and robotic process automation, the introduction of hyperscale clouds, and the accessibility of advanced techniques to create predictions and prescriptions. Working with data has truly become an engineering craft. We have business teams, data engineers, software engineers, data science engineers working together to build entirely new products or consumer offering. This craft requires better tools, more engineered security and protection to account for the decentralized nature of working in the modern agile data environments. Second, we all know from current events, the landscape is becoming more and more complex. Cyber threats continue to grow, and they're continuing to fuse in unique ways that raise the level of complexity. Society, consumers, and governments are demanding action in regard to the responsible use of data, automation, and prediction technologies. The landscape is constantly evolving and requires a speed and scale of action that is making the older ways of doing things no longer successful. I mean, ultimately, all companies have some form of policy making that drives into a set of lines of defenses within the four walls of our enterprise. I mean, that model is pretty much the traditional model that's been around for a while. Policies can be driven by regulation, consumer desires, or changes in societal norms. When these policies are developed, they kick off a set of work. These policies must be engineered to our data systems, our software, and our business processes. We must track business risk and audit compliance. The trick is, and this is what's important, the cycle times in that loop from policy development to policy implementation and enforcement must shorten. We must have modern ways to tie all these lines of defenses together. In some ways, this is not much different than the challenge that we've faced in previous years in the more software area, where we drove to test-driven development, which led us to continuous integration and finally continuous deployment. We have fully automated software life cycle. We need the same level of tooling, capabilities, and sophistication in the tools that we use to protect consumer privacy, data pipeline, data storage systems, and resulting data products. Our systems, our processes must evolve to be driven by ever-changing policies. Our scale must change, our speed must change. It is for these simple and complex reasons that we are very happy to be here and to be a part of moving into the future of data, trust, and privacy. Thanks for your time.
Sorry, thank you so much, Brad. And thank you all for joining us today on these really important topics. Matt put the mailing list link in the chat if you're interested in staying in touch. There will be a lot of workshops and meetings on this subject, and the laws are constantly changing, and we are hoping to really advance some really new technologies to address this. So please do stay in touch. And if your companies are interested in joining us on the journey as well, please feel free to reach out to me directly. But with that, I want to thank you all very much for joining us today. And I know we have a lot of questions that were in the chat that we didn't get to, but I promise I will answer all of you once this is concluded. Thank you again and have a wonderful rest of the afternoon.